I'm John.
I'm Vidya.
I'm Blessing.
I'm James.
And we are Team 5.
Our client, the Tumaini Innovation Center in Eldoret, Kenya, needed an engineering project that could teach their secondary level students some engineering concepts in their school curriculum about solar energy and their other interests.
The constraints involved in this project were that the project had to be made from reusable and renewable materials, should be cost effective, and it should be efficiently integrated into their school curriculum. The product should help students understand engineering concepts that will help them develop skills to reduce energy consumption. So we went through a series of steps to develop our final product as a solution for our client.
Milestone 1 involved us creating our need and problem statements and coming up with the criteria and constraints for our client.
So in Milestone 2, we began the process of concept generation. We listed about 50 or so ideas that would help solve the problem. We briefly described some of the solutions that we came up with, such as solar Legos and Newton's cradle, making use of the idea concept generation strategies like brainstorming and prior art.
In Milestone 3, we shortlisted 8 out of the 50 ideas that we had generated and developed prototypes and sketches to better describe our ideas.
We then proceeded to work on the criteria that we would use to evaluate the solutions that we had shortlisted. We listed out the pros and cons of the solutions that helped us shorten the list down to 3 ideas.
Milestone 5 involved us creating quantitative metrics for the top 3 solutions that we came from our previous list. From there, we assigned importance levels and assigned the weights to create a weighted decision matrix that eventually led us to come up with our final solution that we would present to our client, the Tumaini Innovation Center.
Now that we came up with the final solution, we developed a value proposition for the client and the end users, explaining clearly what made our solution unique and something that would highly benefit their curriculum.
The final design is a completely recycled product that gives the students at the Tumaini Center a way to tinker for themselves and learn about pipe flow and how it can be thought of as an analogy to the electricity flow through a wire and the analogy to Ohm's law.
The model is completely interactive and the students can interchange parts to try different configurations as they please. The connections between the model and electricity is that the pressure in the pipe is related to voltage, the water flow is analogous to current, and the diameter of the pipe is related to the resistance.
By restricting the flow of the water through the pipe, the water flow increases as the pressure stays the same, similar to how it works in a circuit. As the students learn about how the water flows through pipes, they also learn about electricity. And since it's hands-on, it is more engaging with the students than it would be as if it was just a demonstration.
The Tumaini Innovation Center can now make use of our Ohm's Law Lab, a practical live engineering model to impart knowledge about the principles of Ohm's Law to its students using piping, a concept that the students at the Tumaini Center are highly interested in. They will be able to make modifications to the models as they wish due to their knowledge and interest in piping, thus increasing the amount of practical knowledge and expertise that they can achieve in the topics involved.